Okay, so now to transfer a token on behalf of someone else, we need the transferFrom and approve functions. So if you remember, with the approve function, you can set an allowance for your tokens for someone else to transfer. And that someone else is someone you really, really trust. So typically just a smart contract. So you know exactly what it's doing. So let's start with the transferFrom function. To implement the transferFrom, we actually need a second mapping. This is the allowance mapping, which maps from the owner address to the spender address to the allowance value. And this one as well will automatically create this ERC-20 required view function because we set it as public. So we don't need this. We need this mapping to store which owner addresses have approved how many funds for which spender addresses. You will see how this is used now when we implement the transferFrom function. For that, we will also need to do a token transfer, of course. And so that we don't duplicate code, let's first move the existing transfer code into a private function. So we can just copy and paste this, make it private, and give it a different name. And for that, this time we have to pass the sender address as parameter because for transferFrom, it won't be the function caller anymore. So sender, and we change all the msg.sender to sender. And now we can actually use it inside our transfer and transferFrom function. First, in our transfer, we don't have to do anything but just call transfer and keep our msg.sender as sender. Of course, this is the correct name. And now for the transferFrom, let's copy paste our transfer function as a starting point. Copy, paste, and let's call it transferFrom. And we can then add the additional sender parameter, which comes into the transferFrom. And that's what we pass in here. And now before the transfer, we have to make sure the function caller is actually allowed to make this transfer. Right, we don't want anyone to just transfer someone else's tokens. And we can retrieve the allowed value by looking in our allowance mapping. So here we look up the allowance for the sender and the spender. And the spender is just the msg.sender in this case. So and now, in the case the amount exceeds the allowance, we simply revert. And if it doesn't, we update the allowance mapping. And reduce the transferred amount from the current allowance. Now, the last thing missing is, of course, a way for the owner to allow some other address to spend the tokens on their behalf. And that's the approve function, which we can implement now. This takes in the spender address and the approved amount. And of course, it's also external and also returns the Boolean. And now, first, we don't allow approving to the 0 address because it would be pointless doing this. Nobody owns it, so nobody could make use of such an allowance. I mean, this is optional. You could also leave this out. And now we can just set the allowance to the amount which was passed for the person who was calling, which is msg.sender. So allowance msg.sender for the past spender address. And we set the allowance to the amount. And we just return true. And that's an ERC-20 token with all functions implemented. Here. We have a contract now that implements all the required ERC-20 functions. People can transfer the token, approve the token to some other address, and this other address can transfer approved tokens. Are we done? Almost. One small aspect is still missing to call it a full ERC-20 token. Functionally, the contract is already finished, and you could deploy this to the Ethereum mainnet and would have a functioning ERC-20 token contract. But what's still missing here are events. Events? What do we mean by that? Let's talk about it in the next chapter so we can finally finish our first ERC-20 token contract.